Okay, so like everyone's been talking about how to make LLMs even better, right?
Yeah.
They can do some pretty crazy stuff.
Mm-hmm.
But this deep dive is all about a recent research paper that asks like a really interesting question.
Okay.
What if instead of just like making these language models bigger and bigger,
Right.
we actually gave them more time to think when they're trying to answer our questions?
It is a fascinating idea, isn't it?
Yeah.
I mean, the typical approach to improving these LLMs has been to scale them up right.
Right?
More data,
Yeah.
more processing power,
Uh-huh.
and especially more parameters.
And just for those who might need a little refresher, what are parameters again?
Oh, yeah. So parameters are basically like the connections between the neurons in these artificial neural networks.
Oh.
And more parameters generally means you have a more complex and potentially more powerful model.
So instead of just focusing on how big we can make these models, we're exploring if we can make them more efficient thinkers.
Yeah, exactly.
Boy, that.
This paper explores this concept of test time compute,
Okay.
which basically means giving the LLM more processing time after it's already been trained.
So when it's actually trying to like solve a problem.
Yeah, exactly. Like giving someone extra time to work through a really tough exam question.
So did it work?
Oh.
Does giving an LLM more time to think actually lead to better answers?
That's the million-dollar question.
Yeah.
And the results are actually really interesting.
Okay.
The paper suggests that this test time compute could be a real game changer,
Okay.
potentially allowing even smaller LLMs to perform significantly better, maybe even rivaling those massive resource-intensive models that everybody's building these days.
Hold on. So are you saying that we might not need to keep building these like gargantuan LLMs after all?
Right.
That we could get the same performance with smaller, more efficient models?
It's not quite that simple.
Okay.
So this paper focuses specifically on math problems,
Okay.
which are a really good way to test an LLM's like logical reasoning abilities.
Mm-hmm.
And while the current LLMs aren't really great at like dynamically adjusting their thinking time based on how hard a problem is,
Right.
this research is really about seeing what's possible,
Mm.
you know?
So this is still early stage research, but with some really interesting potential.
Yeah.
I'm hooked.
Okay.
Tell me, how do they actually get the LLMs to think harder? What are we changing in the process? All right, so let's get into it. Okay.
How do we actually like train an LLM to think harder?
Well, the paper explores two main approaches,
Okay.
and they both kind of center around this idea of giving the LLM more structured ways to process information.
Okay.
So instead of just like turning in a final answer on a test,
Right.
you're showing your work every step of your reasoning.
Show your work.
Yeah,
Okay.
that's kind of what we're getting at here.
So it's not just about the destination. It's
No.
about the journey,
It's about the journey.
the thought process itself.
Exactly.
Okay.
So one approach focuses on building better verifiers.
Verifiers.
Yeah, so a verifier is basically a system that checks how good the LLM's output is.
Okay.
But instead of just like looking at the final answer, right?
These enhanced verifiers would actually analyze the entire chain of reasoning, like step by step.
Oh, wow. Okay.
Yeah.
So it's like having a more sophisticated grading system
Exactly.
for the thought process.
No.
Okay. Could you give me an example of how that might actually work in practice?
Sure.
Like with one of those math problems that the paper was looking at.
Yeah, so let's say the LLM is trying to solve an equation, right?
Okay.
Instead of just checking if the final answer is correct,
Right.
the verifier would actually look at each step that the LLM took to get there.
Oh, wow.
So did it follow the correct order of operations?
Uh-huh.
Did it simplify terms appropriately?
Right.
And by looking at this whole process,
Okay.
the verifier can provide more feedback,
Right.
which can guide the LLM to better solutions.
So by breaking down the problem and evaluating each step, the LLM can actually learn from its mistakes
Exactly.
and maybe avoid going down the wrong path in the future.
Exactly.
That's interesting. Okay.
Yeah.
What about the second approach?
The second approach.
Yeah, how's that different?
So the second one focuses on actually refining the LLM's initial answer or proposal.
Okay.
It's kind of like if you were editing a draft of an essay.
Okay.
You wouldn't just like submit the first thing you wrote.
Right.
You'd go back, you'd revise it.
Right.
You'd try to make it better.
Okay, I see where you're going with this.
Yeah,
So instead of just giving one answer
Right.
and saying, that's it,
that's it. I'm done.
the LLM is trained to actually be more iterative,
Exactly.
more self-critical. Is that
More self-critical, exactly. So the idea is to train the LLM to generate an initial answer
okay?
and then take a step back and be like, hold on a second.
Interesting.
How good is this, really?
So it's like double checking its work.
Yeah, it's double-checking its work.
Interesting.
It might try different approaches.
Okay.
It might even look for external information,
Wow.
all to try to improve that first answer that it came up with.
So both of these methods, the better verifiers and this iterative refinement,
Right.
they essentially give the LLM more processing steps to work with, right?
Exactly.
More opportunities to catch errors and refine its reasoning.
Yeah, and to be more thoughtful.
Okay.
It's all about making the LLM a more deliberate problem solver,
Even if it takes a little bit longer.
even if it takes a little longer.
So giving these LLMs more time to process more steps in their thinking, it sounds like it could really boost their performance.
It's really interesting, actually.
But I mean, is there a limit?
Well, that's the thing.
Is more always better when it comes to thinking harder?
The paper found that there's a sort of Goldilocks zone
A Goldilocks zone.
when it comes to this test time compute.
Okay, you've got my attention.
Yeah.
Tell me more.
So just like Goldilocks and her porridge,
Okay.
too much or too little thinking can be a problem.
Interesting.
The researchers found that on easier problems, ones that the LLM is already pretty good at,
Right.
giving it too much processing time can actually backfire.
Really?
Yeah, it's like the model starts overthinking things.
It gets in its own way.
Yeah, it starts second-guessing itself, and it can end up going down like a rabbit hole of complexity.
So you're saying it's possible for an LLM to overthink just like us humans do sometimes.
Exactly.
That's kind of funny.
Yeah, it's pretty funny.
But it also makes sense.
It does make sense.
It's like I can definitely relate to overanalyzing a simple problem and making it way more complicated
They're sure.
than it needs to be.
Yeah.
So overthinking is not good. But what about the opposite?
Well, that's the other side of it.
Okay.
On really challenging problems, ones that really push the LLM to its limits, that's when giving it more time to process really, really makes a difference.
Because it gives it that space to explore those different avenues.
Exactly. It lets the model explore different paths, maybe backtrack if it needs to, and really dig into those nuances of the problem.
So it's all about finding that sweet spot.
Right.
The right amount of thinking time for that specific problem.
Yeah.
But that makes me wonder, how do you determine how much thinking time is optimal?
Right.
Is there a way to tell in advance?
Well, the researchers actually found that you can kind of predict the difficulty of a problem for an LLM
Okay.
based on that initial performance.
Oh, interesting.
So if the LLM seems to struggle right out of the gate,
Yeah.
that's a good sign that it might benefit from having more time to process.
So it's almost like the LLM is signaling how much help it needs.
In a way, yeah, that's really cool.
Yeah, it's fascinating stuff.
So does this mean that we could eventually get rid of these massive energy-guzzling LLMs?
Wow.
Could we get the same results with smaller, more efficient models that just think harder?
The paper suggests that it's a real possibility. They actually found that by giving a smaller model the optimal amount of processing time, it could actually do better than a much larger model on some tasks.
Wow, how much larger are we talking here?
In the study, they found that a smaller model, when given enough time, could outperform a model 14 times its size.
That's huge.
Yeah, it's a big difference.
So it's not a complete replacement for large models just yet.
Not quite yet.
But it definitely suggests that there's a path toward more efficient AI development.
It really challenges that idea that bigger is always better.
Exactly. And that's what I think is so fascinating about this research. It's really challenging that conventional wisdom
Yeah.
about just scaling up LLMs. And it suggests that we might be able to achieve even better performance by being smarter about how we allocate our resources. Focusing on that quality of thinking over just sheer size.
Absolutely.
So what does this all mean for you, the listener? It
Right.
means that the future of LLMs might be a lot more interesting than just bigger and bigger models.
It's not just about size anymore.
Exactly. Imagine a world where you have these really powerful but also really efficient LLMs
Right.
on your devices capable of handling these really complex tasks just by taking a little bit longer to think things through.
And here's another thing to think about.
Okay.
This research focused mostly on math problems
Right?
as a way to measure logical reasoning.
Okay.
But what about other cognitive abilities?
That's a good question.
Could giving these LLMs more time to process be the key to unlocking other things like greater creativity,
Interesting.
maybe even better problem-solving skills or a deeper understanding of the world?
Now, those are some really fascinating questions to consider.
Right.
It seems like we're only just starting to understand what these AI systems might be capable of.
I think so.
Well, thanks for joining us on this deep dive into the future of LLMs.
Yeah, thanks for having me.
It's been great having you with us, and for everyone listening, be sure to tune in next time when we'll be back to explore another fascinating topic in the world of AI.